Hello, geometry friends. Today we are going to listen to, watch, take notes on a video about special right triangles. Now, there are lots of different special right triangles, but today what we're going to focus on is something called a 45-45-90 triangle, which means it has two 45-degree angles and a 90-degree angle, and then a 30-60-90 triangle. And what it really boils down to is by the end of this lesson, I need you to just see a pattern and be able to continue that pattern. All right. So this says, let's look at square ABCD. All right. So if this is a square, which it is, I know that this side equals that side and this side equals that side. And I know that that's 90. Okay, cool. Fine. It says label the measures of all the angles. Well, I got the 90s. And one of the things I remember about a square is that the diagonals bisect the angles. So if the corners are 90 and they get bisected, you get some 45s in here. And I have now created two 45-45-90 triangles. Okay, cool. It says use the Pythagorean theorem to find the length of the diagonal in terms of x if the perimeter of ABCD is 20. All right, so if the perimeter of ABCD is 20, it's got four sides. 20 divided by 4 is 5. So all of these would be 5. And so if I really draw this out, like literally draw it out, I have this 45-45-90 triangle here with legs that are of length 5. Pythagorean theorem says a squared plus b squared equals c squared. Let's see, 25 plus 25 is 50. Square root both sides. All right, so if I want to simplify that radical, 50 is 25 times 2, which makes that hypotenuse 5 root 2. Cool. In this 45-45-90, I have two sides that are of a length 5 and a third side that's 5 root 2. Nifty. Number 2. Here's another triangle. Okay. That's 90, that's 45. Well, if they all need to add to 180, this needs to be 45 also. And it says using the Pythagorean theorem, find the lengths of all the missing sides. Well, if these are both 45, that means it has two of the same angle, which means this is isosceles. So if one side is 3, the other leg is 3. And then to find the hypotenuse, I'm going to do a squared plus b squared equals c squared. 3 squared is 9. 9 plus 9 is 18. Solve for the hypotenuse, square root both sides. C is the square root of 18. 18 is 9 times 2. So C is 3 root 2. All right. Starting to notice something here. 5, 5, 5 root 2 in a 45-45-90. 3, 3, 3 root 2 in a 45-45-90. So are the triangles in exercise 1 and exercise 2 similar triangles? Well, the easiest way to tell if things are similar is if they have two pairs of congruent angles. These have all pairs of angles congruent, so yes, all angles are congruent. Okay, all pairs of angles, I should say, are congruent. What's the relationship between the sides within one of the triangles? Well, I have like a leg that equals another leg, and the hypotenuse is multiplied by root 2, right? So it's like leg, leg, and that same number times root 2. And that seems to be true for both. What I can do with that is I can use a proportion to solve for the missing side. So what I can do is say, well, you know what that means? That means that in every 45-45-90 triangle, okay, in every 45-45-90 triangle, I'm going to have sides where it's one side, another side, and then that number times root 2. So I can say this one, that's a 45, a 45, and a 10, is similar to either of the other two. Let's go with the 3, 3, 3 root 2. Those relationships would be the same as this, x, x. Oops, I didn't mean to write root 10, and 10. Feel like I didn't explain that really well. Let me explain again. If I'm going to use a table in proportions, I'm going to match up the similar sides. And I'm going to say, well, in a 45, 45, 90 triangle, I should have a number, another number, and then that number times root 2. So I'm just going to copy those down from a known triangle. Excuse the beep. Then in another 45, 45, 90, I have two missing sides and the hypotenuse is 10. So here's my two missing legs and my hypotenuse of 10. What I can do now is use this table to make a proportion. 3 over x equals 3 root 2 over 10, and then cross multiply. So I have 30 equals x times 3 root 2. Well, if I'm solving for x, I'm going to divide by 3, and that's 10 equals x root 2. Then I'm going to divide by root 2. So 10 divided by root 2 equals x, but I'm not supposed to leave that radical on the bottom, if you remember. So if I want to simplify it, I'm going to rationalize the denominator, which makes this 10 root 2 over 2. And then 10 root 2 over 2 is 5 root 2. So I now know that x is 5 root 2 here and 5 root 2 there. And maybe you're thinking, wait a second, Mrs. Vibber, I thought the hypotenuse is supposed to have the root 2. How come all of a sudden that other side had the root 2? Well, let me explain. What really happens in every 45, 45, 90 triangle, every single one, is if you know one of the legs, you automatically know the other leg, and your hypotenuse is that number times root 2. In other words, if you want to go from knowing the leg to knowing the hypotenuse, you multiply by root 2. But what if you want to go backwards? What if you know the hypotenuse? So let me write this. We did times root 2. What if I wanted to go backwards? What if I knew the hypotenuse and I want to go back and find a leg? Well, if I multiply by root 2 to get the hypotenuse, we would divide by root 2 to get back to the leg. So in the problem that we just did, I have a 10 here. So if I want to go from 10 back to the leg, I do 10 divided by root 2, which is an okay answer, but we're not supposed to leave the radical on the bottom. So once we simplify it, that's how we ended up with 10 root 2 over 2, which was 5 root 2. Okay, and we're going to put that in a box. So in a 45, 45, 90 triangle, if you know the length of either leg in a 45, 45, 90, then you multiply by the square root of 2 to get the hypotenuse. And if instead you know the length of the hypotenuse, you divide by root 2 to get the length of the leg. Okay? So if I come down here, I have 45, 45, 90. I know the hypotenuse. So if I know the hypotenuse, I'm going to divide by root 2 to get this one. So this is going to be 4 root 2 divided by root 2. This is just 4. If this is a 45, 45, 90, the legs have to be equal, so the other one's 4. I come over here. Here's another 45, 45, 90. If one side is 2, the other side is 2, and the hypotenuse is that times root 2. That's it. It's just a pattern. The diagonal of a square garden has a length of 50. Okay, so if I have a square, again, ignore the dinging, and my diagonal is 50, I know, oh, wait a second, if this is a square garden, then these are 45s. So it says the diagonal's 50. What's the perimeter of the garden? Well, if I need the perimeter of the garden, I really need to know the lengths of the sides. And then I say, oh, look, there's a 45, 45, 90. If I know the hypotenuse, I divide by root 2 to get the leg. 50 divided by root 2. I got to rationalize the denominator. So that's 50 root 2 over root 2 times root 2, which is 2. Remember, when you multiply a radical by itself, the radical disappears because root 2 times root 2 is root 4, which is 2. And then 50 divided by 2 is 25. So this leg is 25 root 2, which means so is this one, and this one, and this one. So I have 25 root 2 times 4, which is 100 root 2 is our perimeter. And that's 45, 45, 90 triangles. Well, that's one special right triangle. The other one is a 30, 60, 90 triangle. So in a 30, 60, 90, it says triangle ABC is equilateral. All right, fine. Equilateral means that all of these would be equal, and the bottom would be the same as well. And it has a perimeter of 30. Okay, so 3 sides, perimeter 30. That means each of them is 10. So 10 here, 10 there. And when I draw down the altitude of an equilateral, it splits the bottom in half. So I got 5, 5, and 10. Well, also, if this is equilateral, in an equilateral triangle, all of the angles are 60. So this would be 60, that would be 60. And when you drop an altitude, it cuts this angle up top in half. So that's 30. And the altitude makes a 90-degree angle with the bottom. Here's where 30, 60, 90s come from. Now, why do we study 45, 45, 90s and 30, 60, 90s? Well, because a 45, 45, 90 comes from a square, and a 30, 60, 90 comes from an equilateral triangle. And squares and triangles show up a lot in mathematics, so it's worth it to us to study these specifically and call them special. All right, so I got all that. And then it says find the measures of the angles, done. Find the lengths of the sides, done. Use the Pythagorean theorem to find the missing lengths. Well, I'm only missing one of them. I'm going to do this one. So I'm going to do a squared plus b squared equals c squared for this right triangle right here. That's 25 plus x squared equals 100. I'm going to subtract 25, making x squared 75, not 72, 75. Square root them both. 75 is 25 times 3, which makes that height 5 root 3. Cool. Okay. Now it says nothing. That's all I had to do. So let's look at these. I have a 5, I have a 5 root 3, and I have a 10. What happens next? Explain why the two triangles are similar. Well, they're similar because they have two pairs of congruent angles, because I have a 90, a 60, a 60. And since 90 plus 60 is 150, these are both 30. Then it says use proportions and or Pythagorean theorem to find the lengths of all the missing sides. Okay, fine. Well, this is 5. This is 10. We just learned that this other one is 5 root 3, so I'm just going to use, my previous knowledge. And now I'm going to use the fact that they're similar to make some proportions and say, okay, well, let's set up a proportion. In this figure, the bottom is 5, the hypotenuse is 10. In this figure, I'll call the bottom x and the hypotenuse is 8. So 5 to 10 should be the same proportion as x to 8, the same ratio as x to 8. Cross multiply, 40 equals 10x. Divide by 10, x equals 4. Okay. And now that I know that this is 4 and that's 8, I could do Pythagorean theorem and say a squared plus, we'll call this b squared equals c squared. 16 plus b squared is 64. Subtract the 16. You get 48. Take the square root. And then I say, okay, what perfect square goes into 48? 48 is 16 times 3, which is 4 root 3. Now let's look at the relationship here. 5, 10, 5 root 3. 4, 8, 4 root 3. No, your video didn't freeze. I'm waiting, hoping that you're thinking about what you notice. What's the relationship between the sides? Well, the hypotenuse is 2 times the smaller side, and then the larger leg is the smaller leg times root 3. 4 times 2 is 8. 4 times root 3 is 4 root 3. 5 times 2 is 10. 5 root 3. Okay? So what happens is when you have a 30, 60, 90, the side across from 30, the smallest side can be whatever it wants. I'm going to use the 5. The side across from 60 is 5 times the square root of 3, and the side across from 90, your hypotenuse, is 5 times 2, which is 10. So if in one 30, 60, 90, I had 5, 5 root 3, and 10, then in this other 30, 60, 90, the side across from 30 is x, the side across from 60 is 5 root 3, and the side across from 90 is y. Hey, look at that. This is the same as what we had before. If this is 5 root 3, then this little side is 5, and this is twice that. Okay, let's bring it all together. If you know the length of a short leg in a 30, 60, 90, then you multiply by 2 to get the length of the hypotenuse. And if you know the short leg, then you multiply by root 3 to get the long leg. And those can be reversed. If you knew the hypotenuse, you would divide by 2 to get the short leg. If you know the long leg, you divide by root 3 to get the short leg. But the key here is the short leg is the linchpin. That short leg is what makes everything go together. Did I use that phrase appropriately? I'm not sure. The short leg is the keystone. Maybe that's a better analogy. All right, so let's go to here. Find the value of each variable. I have the hypotenuse. The hypotenuse is always twice as big as the short leg. So I'm going to divide by 2 and get 4. And then once I have the short leg, I multiply by root 3. In this last one, I have a 30, 60, 90 here. It says the longer leg, which means the one across from 60, is 6. Find the length of the hypotenuse. Well, here's the deal. We said if I knew the short leg, I would multiply by root 3 to get the long leg, which means if I go backwards, I have to divide by root 3. So 6 divided by root 3 is 6 root 3 over 3, which is 2 root 3. This side right here is 2 root 3. If I know the short side, I double it to get the hypotenuse. 2 times 2 root 3 is 4 root 3. Okay, it's all based on patterns. So when you do your homework, you're going to decide is it a 30, 60, 90 or a 45, 45, 90? And then you're either going to do side, side, side times root 2 or little side times root 3 and double. One thing I want you to write at the top of your homework is just a reminder picture. If you have a 45, 45, 90, x, x, x root 2. It reminds you that two sides are the same and the hypotenuse is times root 2. And if you have a 30, 60, 90, the side across from 30 is x. The hypotenuse is always double that. And the side across from 60 is that times root 3. All right, I am done. I hope you're all having a great day and continue to do so. Go try your homework. Bye.